Math Extra. This is Saritha. Today we are going to discuss the topic of circles. So what is a circle first? See, in a plane there are infinitely many points are there. Yes, if you consider a plane. So this is a plane. Yes. So let us consider this is a plane. In this plane there are infinitely many points. What I am doing? I am fixing one point. This is a fixed point. I am locating a fixed point and I am collecting the points which are equidistant from this fixed point. Suppose if I want to take the equidistance as like this. Okay. Yes, I am collecting all the points which are equidistant from this fixed point. Okay. So if you go on collecting the fixed point, it will look like this. So this is nothing but collection of the points which are equidistant from the fixed point. So this we call as a circle, and this fixed point we call it as a center of a circle and we denote it with C. Okay, and this equidistance, yes, this equidistance we call it as radius of the circle. So this we can denote with small r. Okay. This circle is also a polygon. How can we say this is a polygon? See, we cannot see the line segments here, isn't it? But why we call this as a polygon? See, in the polygon, if you go on increase number of sides, what happens? Automatically the length of the side decreases. So if you increase the number of sides up to infinity, then what happens? The length of the line segment becomes very small and somewhere sides of infinity, that time it will come to the length of simple point, isn't it? So that time it looks like the circle. That is why we also call circle as a polygon. Polygon of n sides where n tends to infinity. Okay. How can we define radius of the circle? See, just now we have seen that a constant distance we call it as a radius of the circle. But in other way, it is nothing but the distance between the point center and any point on the circle. Because as we are collecting equidistant points, if you take any point, the distance from center to the point on the circle is always constant. So that we call it as a radius of the circle, and radius is always a non-negative number, which is nothing but r must be greater than or equal to 0. Why? Because the radius is nothing but it is a length. Length cannot be in negative value, right? That is why the radius is always a non-negative number. What is non-negative number? Means it can either be 0 or greater than 0, but it is not in negative. Okay. So when it becomes 0, see here the point circle come into picture. What is a point circle? Point circle. This point circle. What is a point circle? If the radius of the circle is equal to 0, then we call that circle as a point circle. How it looks like? It is nothing but if we consider this is a plane and this we call it as a point circle. As the radius is equal to 0, this point circle consists only one point and that point we call it as a center of the circle. Okay. The point circle always consists only one point. That fixed point we call it as a center of a circle. Okay. This is a point circle. What is a unit circle? If this radius is or equal to 1 unit, then we call that as a unit circle. Means that 1 means it can be 1 meter, 1 centimeter, 1 kilometer, whatever may be the measurements. The radius of the circle is always equal to 1. Then we call that circle as a unit circle. Okay. Consider any circle other than point circle. As point circle consists only one point, right? If you consider any other circle other than the point circle, that circle contains infinitely many points. See, what we in the definition itself we have discussed that the circle is nothing but the collection of points, right? So these are the points, infinite points we get. That is why, so if you consider any circle other than the point circle, there are infinitely many points are there. Okay. If you consider point circle, there is only one point which is center of the circle. Okay. Position of a point. See, in a plane, this is a plane and we are considering a circle in this plane. Okay. So this is a center. Consider any point in this plane. So in the plane, if you consider any point, we have to decide the position of that point with respect to circle, because this circle divide this plane into three parts, which is nothing but this is exterior of a circle and this is interior of a circle, and third one is on the circle, which is on the boundary of a circle. So these are the three different positions we have with respect to circle. So if we take a point, so we have to decide the position of a point with respect to circle, whether it is exterior to the circle, whether it is interior to the circle or on the circle, we have to decide. Okay. So if we have a point outside the circle, then this point is we call exterior point of a circle. Okay, if you consider interior, any point interior in the circle, then we call this is a interior point of a circle. And if you consider any point on the circle, this we call it is point on the circle. Okay, but by only the given statements, how can we decide whether the point is exterior or interior on the circle? See, for that we are considering a circle with center C and this is the radius of the circle, or we call it as a radius of the circle. And how we are defining D as a, D is nothing but distance between the center and the point P. We don't know where we consider the point. So whatever may be the position of point, we are defining the distance between the point and center of the circle as a D. Yes, and R is nothing but radius of the circle. So we have a relation between the radius and the distance between the point and center. Depending upon that, we are deciding the position of the point. See, if the point is, if this distance is, let us consider this is a distance D and this is a radius R. Okay. If this radius R is less than D, if R is less than D, what happens? Means this is the radius and this is the distance. Now we are saying this R is less than this distance. Means if this distance is more than the radius, right? This is, we call it as a radius, a point on the circle to the center of the circle. This is radius. Obviously, we are extending the distance up to the point P. That is why we are saying this radius is less than the distance D. So by this relation we can say that the point P position is exterior of the circle, which is nothing but it is exterior of the circle, isn't it? And if R is equal to D, what happens? So this is the radius R and again this is a distance D. Okay, means that both radius and the distance between the point and center are equal. Means the point is on the circle, then only it is possible to equal the radius and the distance between those points. That is why if R is equal to D, then we can say that the point is on the circle. Wait, what is the position of the point? Which is on the circle. Okay. If R is greater than D, so if R is greater than D, what happens? If you consider the point here and this we are considering D distance. Okay. And up to here, this is R, isn't it? Now what happens? This radius is greater than the distance D. That is why we can say that the position of the point is interior of the circle. Yes, the position of the point is interior of the circle. This is how we can define the position of the point with respect to the circle. Okay. And these both exterior points of a circle and interior points of a circle always don't belong to the circle. The circle is nothing but this boundary line. This boundary line we are calling a circle, isn't it? But we have so many points interior of the circle. We have so many points exterior of the circle. But that both exterior points as well as interior points don't belong to the circle. Okay. And as the center is also interior of the circle, the center also does not belong to the circle. You remember this statement, center does not belong to the circle. Only the points which are on the circle always belong to the circle. Okay. What is a circular region? See, if you consider this is a plane and this is a circle. Okay. Yes, this is the center of a circle. Now, what is a circular region? Circular region is nothing but the, the interior of the circle and on the circle. The points which are interior of the circle and on the circle, we call that total region as a circular region. A circle along with its interior. See, if we shade this region along with the circle, this circle along with the interior of a circle, this total region, we call it as a circular region. Okay, this is a circular region of a circle. They may give some points on the interior of a circle and P, Q, R, and some points on the boundary of the circle, which is A, B, C. So they may ask the question that which points are belong to the circular region. So if you ask the question that which points are belong to circle, then that time we have to answer that A, B, C or belong to circle. Okay. If you ask for this which points are belong to circular region, then we have to consider interior points also. Along with the PQR, you should consider the center of the circle also because that is also interior of a circle, right? So, along with the center PQR and on the boundary points ABC, all are belong to the circular region. Okay, center of the circle, or we have seen that the center of the circle does not belong to the circle, but it always belong to the circular region. Okay, the center always belong to the circular region but not to the circle. Okay, thank you.